Start back in 1946. Millions of people in India needed affordable shelter. Companies like Hyderabad Industries Limited stepped in to produce roofing materials on a massive industrial scale. But building a nation takes a heavy toll. For decades, the backbone of Indian construction has been the traditional red brick, baked in kilns that pump dense, toxic smoke directly into the atmosphere. Stacking these bricks requires grueling manual labor. The environmental cost eventually became so severe that local governments started banning red brick manufacturing entirely. Meanwhile, in rural areas, millions are still migrating from fragile, thatched roof huts to basic fiber cement sheets to keep the rain out. The demand for raw building materials is relentless. This creates a massive problem. An 80-year-old heavy manufacturing giant has to figure out how to supply materials for rapidly expanding cities and rural towns without completely wrecking the climate in the process. Hill's solution replaced the standard take, make, waste industrial model with a five-way green philosophy, re-engineering their factory floor into a closed loop. Instead of mining new resources, the primary raw input is industrial waste, diverted from landfills and fed directly into mixers. To power the massive machinery required, they tapped into renewable energy. Wind farms across Tamil Nadu, Rajasthan, and Gujarat now supply over 30% of the total electricity needed to run the plants. Inside the facility, the production process is sealed off. Water and gases are trapped, filtered, and continuously recirculated through pipes instead of dumped out. The operation yields zero gas emissions, zero liquid effluent discharge, and zero unusable byproducts. It proves that heavy manufacturing doesn't require a toxic footprint. You can process garbage into the literal foundation of a new home. That foundation is now built on advanced Aerocon panels and AAC blocks. AAC stands for Autoclaved Air-Rated Concrete, a lightweight precast building material that provides both structure and insulation, steadily replacing heavy fiber cement. This architectural cross-section highlights a mechanical advantage. A standard concrete wall requires heavy steel rebar, while Aerocon partitions function with negligible steel, drastically lowering the building's weight. They also provide high thermal insulation, blocking harsh heat and reducing cooling energy by 28%. Less steel, faster installation, and lower energy bills compound quickly. Developers end up reducing their overall project construction costs by up to 30%. That precise engineering approach allowed Hill to expand into advanced polymer piping. They rolled out UPVC and CPVC, high-strength plastic polymers used for plumbing, featuring a true fit technology designed to guarantee completely leak-proof joints. These blocks and panels provide superior thermal insulation compared to traditional brick, while remaining significantly lighter and cheaper to deploy. This level of factory efficiency eventually registers on a global scale, catching the attention of international climate auditors. The United Nations Framework Convention on Climate Change certified HIL's Golan plant to earn between 35 and 40,000 carbon emission reduction points every single year for the next 10 years. A CER is a globally recognized metric representing 1 ton of carbon dioxide removed from the atmosphere. This chart tracks the financial momentum behind the shift. Look at the traditional sheeting market over a 4-year period. It actually contracted at a compound annual growth rate, or CAGR, of 1%. Now watch the supply of AAC blocks. Spurred by government bans on red bricks and heavy demand from affluent states, this sector exploded with a 50% growth rate over 6 years. But engineering the perfect building material creates a secondary bottleneck. A highly efficient, leak-proof polymer pipe is entirely useless if the person installing it doesn't know how it works. To solve the labor gap, HIL partnered with an NGO called Shramita. Together, they actively recruit economically challenged young people from the rural villages near their factories. These recruits are put through intensive training to become certified masons, electricians, and plumbers, guaranteeing them a steady livelihood and providing the industry with a modernized workforce. Sustainable construction relies on a combination of zero-waste factories, international carbon credits, and a certified workforce trained to install these advanced building materials.